The U.S. population can be viewed as a function of time. So as time goes on, the population is changing. We have a graph of how the population is changing in millions given the year. And then we also have a table listing those populations from 1790 to 2010. And we're going to use that to calculate slope or average rate of change in a population per year. And this part says from 1800 to 2000. So we're going to look at those 2 years. So 1800, the population was 5.3, and that stands for million people. And then 2000, the population was 311.4, and that's million people. So if it's helpful, we can write these as points. So we have the point 1800, year 1800 had 5.3 million people. We can tell that this is the X and this is the Y by looking at the graph, how we should write the points. So we're going to call this one X1, Y1. And then our other point is 2000, 311.4. And we have our X2, Y2. That way we can plug into the slope formula. So just to remind ourselves, the more we write it, the easier it's going to be to remember. The slope is the difference in your output or difference in y's. So y2 minus y1 over difference in x's, x2 minus x1. So if we plug in for this one, we want the average rate of change between these two y values. So y2 is going to be this 311.4 minus y1 is the 5.3. So I'm going to do 311.4 minus 5.3, difference in y's, over, now I need to look at the x values, so difference in x's. So 2000 minus 1800. And so I'm just going to grab my calculator and do 311.4 minus 5.3, which is a difference of 306.1 million people, is what that numerator is measuring, divided by the difference between those years. So I'm going to do 2000 minus 1800, so that's 200-year difference. And when I divide those, I'm going to do 306.1 million people divided by 200 years, means the average rate of change is 1.5305, and that's million people per year, right? Because the numerator measured million people and the denominator measured years. But it says to round to 2 decimal places. So I'm going to look at the second decimal place, and I'm going to decide, do I keep it a 3 or should I round it up to be a 4? Well, looking at the number after, I have a 0. So I'm going to keep it a 3 instead of rounding it up to being a 4. So my final answer is 1.53 million people per year. And now we're going to write our sentence interpreting this. So first of all, we need to state that this is on average. This is not every single year that this is the exact rate of change. This is on average. The population, what was it doing? Was it increasing or decreasing based upon our answer? Well, it's a positive 1.53, and we can also look at the numbers. The population went from 5.3 million people all the way up to 311.4 million people. So we know it was increasing, either by seeing our positive answer or just knowing that the numbers got bigger by a lot. So on average, the population was increasing by 1.53 million people per year. And this is not every single year. This is on average, and it's between 2 specific years. There could be other years where we would look and it was a huge jump or something, like looking just between these 2 years. We're going from 88 to 104. That seems like a bigger change. So we're not going to say that this is always true. We want to give our specific time frame. So on average, the population was increasing by 1.53 million people per year between and we said 1800 and 2000. So we have the 4 things that we need. We said that it was on average, which is necessary. This is an average rate of change. We said whether it was increasing or decreasing, by how much with units, and on what time frame. On average, the population was increasing by 1.53 million people per year between 1800 and 2000.